embark on this exciting journey. But before we dive into the world of machine learning, let's break the virtual ice. Give me a quick hello or react with your favorite emoji. Awesome. Without a further ado, I'm delighted to introduce our AI and ML lead, Uzair, who will be guiding us through this incredible experience. Over to you, Uzair.
Hi everyone. Once again, a warm welcome to you all in the first session of our ML study jams. Without wasting much time, I'll be just introducing the team and let's get into it. So we have Chandana, Siddharth, Mahmood, and Aman in our team who will be taking over the session. Chandana, over to you.
Everyone, this is Chandana. So let's start the session. Have you ever wondered how self-driving cars work, or how shopping websites like Amazon, Flipkart knows the products we might like, or how our keyboard predicts the next word we are going to type? This is all because of machine learning. Next slide. People often use artificial intelligence, machine learning, and deep learning interchangeably, but there are few distinctions between them. In simple words, artificial intelligence is a type of intelligence that mimics human intelligence. In machine learning, we create models to solve some specific problems. That means we create some specific models, solve some specific tasks. Next.
Chandana, you can unmute yourself. Chandana, you are on mute.
This is a simplified overview of the history of ML. Algorithms. Algorithms were formulated centuries ago from statistics, linear algebra, physics, and biology. But due to lack of data and low computational power, ML was not used extensively. But now, for the last few decades, sufficiently large amount of data were collected to train models, and now we are having relatively cheap and fast computing power machines to solve complex calculations with high accuracy levels. So now, with integration of big data, algorithms and technology, machine learning was now used extensively. Next slide. Here's the definition of machine learning, which says machine learning systems take inputs to learn, then make useful predictions and decisions about unseen data, which basically says that based on known data, it makes the predictions about unseen data or unknown data. Next slide. Here's another definition of machine learning, which says machine learning is a field of AI where a system learns certain examples in order to make future predictions. That means it only learns certain examples to make future predictions that are also correct predictions. Next slide. Here's the same definitions, but it is articulated in a more formal way, which says computers learning how to do a task without being explicitly programmed to do so. That means the ability of a computer to learn about a specific task without being explicitly programmed or written. Next slide. Features. Features are like properties. In machine learning, there is a concept called feature selection, where we select only those features which help us to achieve our goal. For example, for predicting the price of the house, here are few features listed out, and now we should check whether these are the features will contribute to the price of the house or not. Location. I think location of the house is a major factor we consider. Number of bedrooms. Whether the house is of 3 BHK or 2 BHK, the price differs. Size of the property. Whether the house is situated or constructed in a 300-yard place or 200-yard place. By this, the price of the house differs. Now, number of lights and switches. I think this factor or this feature we don't consider while predicting the price of the house. Color of the house. Again, this feature we don't select while predicting the price of the house. So, above are the three features we select while predicting the price of the house. Now, that means these features contribute more for predicting the price of the house. Next slide. Now, you guys say for recommending a video for a user to watch next, what are the features you consider? Topic or popularity of a video or number of views, or creator of video, or length of the video, or age of the video. I think length of the video and age of the video are the factors we consider. Why? Because we don't usually watch the videos which are released 3 years or 5 years back, and we don't watch long videos. Now, Aman will continue.
Hello, am I audible? Hello?
Yes, Aman, you're audible.
Yeah, so, hey guys, Aman this side. So, yeah, let's start this. The process of training a machine learning model is actually quite interesting. The first step in it is the data acquisition. So, basically, in this step, for training a model, the most important part of it is to acquire data. So, basically, in this step, we collect our data to train our model. Now, this data can be from different sources like organized databases, simple spreadsheets, or even using APIs. Now, the next step is data exploration, in which basically our primary goal is to understand the structure, patterns, and characteristics of the dataset. Now, how this data exploration helps us is it is crucial for making informed decisions about data pre-processing and model selection. The next step, data cleaning, we have feature engineering and feature selection. So basically, feature engineering refers to modification or creation of new features from the existing dataset that is basically done to improve the model's performance. Now, this could involve transforming variables, handling missing data, or creating new variables that better represent the patterns in the data. And next is feature selection. So choosing the most important feature that contributes significantly to the model's predictive power. So this helps us in reducing the complexity and improving the model interpretability and enhance efficiency. Now the next part is modeling, in which we have test data. So test data is basically the splitting of data set into training and training sets. Now how training set and the training and testing sets helps is the training set is basically used to train the model, and testing set is reserved for like evaluating its performance. So this will help the model to generalize to new and unseen data. And the next step is model training and building. So this step is really important because in this step we basically choose a model. So you can think of choosing a model as picking the right tool. So like think of it like selecting the right tool for a job. Like if you want to predict categories, for example, which animal is it? So you might choose a certain tool. If you want to predict numbers, like how much will it rain tomorrow, you choose a different tool. So these tools are nothing but machine learning algorithms, which basically play a huge role in our model training. Now, like example, if you're like predicting if an email is spam or not, this is actually used. So if you are predicting if an email is spam or not, you might use an algorithm that's good at sorting things into categories. And like the next one is training the model. So think of it as teaching a computer brain. Imagine you're teaching a computer brain to recognize patterns just like you recognize patterns in everyday life. The computer looks at examples of data that you have provided and distinguishes between them. So let's say if you have lots of pictures of cats and dogs, you will use this to teach the computer what features like ears, tails of the animals are important for distinguishing between them. So this can be used for distinguishing between different images. Now the final one is model testing. So after we are done training the model and choosing the model, now we have to test it. So to check its efficiency and how is it working. So to measure its success, we have to use evaluation metrics. So the metrics can consist of accuracy, precision, recall. So like let's say if we are creating a model that says if a mail is spam or not. Now accuracy will help us how often is the model correct. And like when it says an email is spam, how often is the mail actually spam? And the next step is fine tuning. So fine tuning basically refers to the process of making small adjustments or modification to a pre-trained model to adapt it to a specific task or data step. So after we are done with training and testing our model, now the final step is deploying it. So after we are done with everything, we just deploy it. So basically deploying in simple words means after we are, taking the model out of its practice room and putting it into a real world scenario where it can work its magic on new data and also integrating it. So we basically integrate it to our existing systems and processes and see how it works in the real world. Can I have the next slide, please? So machine learning model is broadly classified into supervised and unsupervised learning. And in supervised learning, the machine learning model is basically trained on labeled data. And what it basically means is it refers to a data set in which each instance is paired with its corresponding output. So, like in other words, its data point in labeled data set is associated with a known outcome or category. Now, it has classification and regression in it, and unsupervised learning is basically the algorithm is given unlabeled data and must find patterns or relationship within the data without our guidance. The next slide. So the supervised learning basically consists of classification and regression, and the unsupervised consists of clustering, which we will get to know more about by Mahmood.
So hello everyone. My name is Mahmood Qureshi. I am from CSC fourth year, and I will be explaining to you about different tasks which we can perform using machine learning. The first basic task which we can perform using machine learning is classification. Classification is simply labeling different input data which we give to the machine. A machine simply labels different data which we are giving it in the form of input. It works on labeled data. We provide the machine learning model with labeled data so that it can classify different images, texts, or any other things. Like for example, this image of a lion, the machine learning model will be able to classify it as a lion or as wildlife or as mammal because of different class labels that we give it. The main goal in machine learning is to generalize how the training data can make easy predictions based on the model. Examples of machine. One second. The example of classification tasks include spam detection, whether an email that you are getting can be classified as spam or not spam, or whether we can classify different images. For example, an image of a dog or a cat. If we provide the image to the machine learning model, it will be easily able to classify it, whether it is a dog or is it a cat. Who's that next slide? The next other task that uses supervised learning as a basis is regression. In regression, basically, we are trying to find a linear relationship between a dependent variable and an independent variable. For example, let an independent variable be y and a dependent variable be x. Now we are trying to find x through y. The main goal in regression is to find how two data points or two variables are dependent on each other. Examples of regression can be predicting house prices, like whether depending on the area, how the house price may increase or not. It can also be stock prices, how depending on the company the prices increase, or how depending on investment the price increase. Who's that next slide? Clustering is an unsupervised learning method. In unsupervised learning, we don't give the model labeled data. The model has unlabeled data. There are no classes present. Just to classify, it is basically an unstructured data. The model itself will work with unstructured data to give us structured output. In clustering, we work with clusters. Clusters are basically groups of data points that are very similar to each other. So they are called clusters. The main goal of clustering is to classify objects or data points that are very similar in features or attributes to each other. An example of clustering would be anomaly detection or image segmentation, like how different segments of an image are similar to each other, or like customer segmentation, like how different type of customers can be used to form clusters and how they shop and how different purchases they make. Now let's look at some examples using for the types of machine learning. Labeling email as spam or not spam. As we are classifying whether an email that is being sent to us is spam or not spam, that's why we use classification for this task. Identifying famous landmarks in a photo. Like for example, if we give a machine learning model that works on classification of picture of Taj Mahal, it will classify it as Taj Mahal. So as it is being given a label, it is used as classification. Identifying trends among a group of people who have bought a new music release. Like how in malls, if we go, how different customers, how different items are placed in different areas for different customers. Like if people prefer a specific type of music or a specific type of artist, then it will be easy to cluster them, like form a group of them and present a playlist to them of how people listen to that music. Suggesting spelling corrections. Like in our phones, we have autocorrect, and it also gives us suggestions based on how and what we are trying to write. Like it checks the sentence that we are trying to form, or it checks the spelling and suggests us different spellings or different words. As it forms different group of words that sound similar to each other or have similar spellings, it suggests us the correct spellings. Predicting the quality score for an advertisement. Like for example, if the advertisement is good, the quality score will be good. If the advertisement is good, more number of people will be attracted to it. So it depends on how good the advertisement is. Like for example, if advertisement is X, we are trying to predict Y, which will be how many number of customers or people are going to be attracted to that advertisement. Estimating arrival time based on a time of day or traffic. Like for example, if we are commuting from our homes to our college, let's say the distance between our homes, between our home and the college is 5 to 10 kilometers. Let's take 10 kilometers. The time taken should be around 20 to 30 minutes. But depending on the time of the day you leave, like if you leave during rush hour, it will take a lot of time. If there is a traffic or roadblocks are there, it will take more time. So depending on how the road is, how the traffic on that specific day is, like it is a rainy day or a normal day, it depends on the day. So the time of arrival you have coming to our college will be the what is the flow of traffic on the road and what time of day it is. Is it rush hour? It is normal time. So we are trying to find the relationship between our time of arrival and the type of traffic or the time of the day. Now Siddharth will continue about NumPy and Pandas.
Am I audible? Yes, Siddharth, you're audible. Yeah. Hi everyone. I am Siddharth. So before learning how to build a model, you should be knowing what NumPy and Pandas is. So like NumPy stands for numerical Python, and it is a library used for working with arrays. It also has other functions we can work on, like linear algebra, Fourier transforms, and matrices. And it is a open source library which we can use freely. To install this NumPy library, we can use the command pip install NumPy in Python. So we have few methods in NumPy which we'll be using most commonly. So the first one is np.array, which will be creating a array, and the next one is numpy.zeros, which will be creating an array of zeros, and numpy.ones, which will be creating an array of ones. And numpy dot arrange is a most common function used for one dimensional array. Like if we pass a value in that, for example, if we pass a value 20, it will be creating a array of 0 to 20. So we also have a few array manipulation functions in numpy, like for example np dot reshape, which will be telling which in which we can reshape our array size. So next is pandas. The name pandas has referred to both panel data and Python data analysis. Uh, like Python is also a library which is used for working with data sets. It has functions for analyzing, cleaning, exploring, and manipulating data. You can install pandas using the command pip install pandas in Python. So, so Python is also an open source library, and we have a few methods in pandas, like pandas dot data frame, which will be creating a data frame. Data frame is nothing but rows and columns. Like if we pass a list, it will be creating a row. And pd dot read csv and pd dot read excel. If our data set is in the form of excel sheet or a csv, we can read that csv and excel sheet using this pd dot read csv. Pd is nothing but alias of pandas. And next method is uh, df dot head, where df is the data set, and we are printing the head of the data set, nothing but we are printing the first few rows of the data set, and df dot tail is the last few rows of data set. And df dot info, it will be printing the information of a data frame, like column names and size of the uh, data set and all. So that's all about pandas and numpy. So the next topic, model building, will be explained by Uzair.
Is my Colab screen visible?
Yes.
Yeah, okay. So before starting, let's just have a look at the data set that we'll be using first. So this is the data set that we'll be using. It has mainly 4 columns. That is this data set is about flowers. That will be describing the sepal length, sepal width, petal length, and petal width of a flower. And then the labels of it is like the category or the species of flower that the certain flower belongs to. So like I've loaded the CSV file into my Colab. Now let's just start coding. As Siddharth has told that we'll be using pandas for data manipulation and everything. So we have just like imported pandas. We are creating a variable called df that will be storing our data frame. So here this is our data frame, which is having ID, sepal length, sepal width, petal width, and species. Out of this, the ID column is not at all needed for doing the prediction. So for training our model, we'll be just needing this sepal length, sepal width, petal length, and petal width column. So we'll be storing this in a variable called x. So we have just stored the 4 columns in a variable called x. Now the target, we'll be storing the target, that is the species, in a variable called y. Okay, so like our data set is having around 150 columns. So first we'll be like splitting them into training set and testing set. For that we have a method in sklearn that is called train test split. I'll be just importing it. So this method train test split will be returning 4 values. Those 4 values are x train, x test, y train, and y test. As we can see, the first one we'll be passing the data. I mean the training data, that is the x value, the x columns. Those are the 4 columns that we have selected, and also the target variable, that is y. And then we'll be specifying a test size that is around 20%. We can either specify the test size or the train size depending on whatever we feel easy. And then we also have a parameter called shuffle that will just shuffle the data while splitting the data. So our data set has been split into train and test. We'll just have a look at each one of them. We're having around 120 rows for our training set. And we're having the remaining 30 rows for testing. These are the corresponding labels for the training data, whereas the y test is the corresponding labels for the test data. So y test is actually used for actually calculating the accuracy of our model. For now we'll be using the decision tree classifier algorithm. It's present in sklearn again. We'll be storing the decision tree classifier algorithm in a variable called CLF. Now we need to train our classifier on the X train and Y train. So there's a method called CLF.fit. So this line over here, the training of a model is completed. Now we'll be predicting the x values, that is the x test. And we'll be storing those predicted values in a variable called pred. Now we'll be computing an accuracy score to find out how well our model has performed. That is again present in sklearn. Y test are the 2 values that we have separated while we have been splitting the data, and pred is the predicted values. So we can see that we have got an accuracy of 93%. Now for example, I want to give a new instance. I'll simply write clf.predict. I'll just give the value 5, 3, 1.6 and 0.2. So here, like our model has specified that it belongs to the species Setosa. We'll be sharing you the code after our session has concluded. Now I'll be passing on to Abrar. He'll be explaining about the solution challenge. Abrar, on to you.
Hey everyone, I hope you all enjoyed the introduction to ML model building. Now let's move on to our next agenda of our session. So, are you all passionate about solving real world issues and want to make a difference? Look no further than the Google Solution Challenge. Today, today I am thrilled to introduce you to the Solution Challenge, a global platform designed to empower students like you to become change makers. The world we live in faces numerous challenges from climate change and poverty lack to okay, the world we live in faces numerous challenges from climate change and poverty lack of clean water and access to education. These issues are complex and interconnected, demanding innovative solutions. That's where Solution Challenge comes in. This is an annual competition that encourages you to harness the power of Google technology like Cloud Platform, Android, Flutter, and Firebase to tackle these pressing issues. The challenge focuses on finding solutions related to the 17 Sustainable Development Goals by United Nations, which are expected to be achieved by 2030. Few of the goals include no poverty, clean and sanitation water, decent and lot more. So in other words, Solution Challenge is a global level hackathon to solve the 17 Sustainable Development Goals by United Nations. So if you run out of ideas on what to build, you can take a look at last year's Solutions Challenge winners projects on this website. One second. Yeah. So you can go to this website and have a look at last year's winners projects. I will share this website with you after this session. So to be more precise about the type of solutions to be built, I'll explain with an example. Let us take one development goal for instance. Let us go with reduced inequalities, which ensures that all the specially abled persons are treated equally. So for them, you can build a mobile application for hearing impaired individuals, allowing them to understand what others are saying through lip reading. You can incorporate concepts of computer vision and various machine learning algorithms to achieve this. In this solution, you will be building an Android application for the user interface, leveraging Google technology, and you can use the Google Cloud platform to manage the database and other API services. Remember, priority for shortlisting will be given to AI and ML projects. I hope that clears your confusion on what type of solutions to be built. So here's the timeline for Solution Challenge. It is designed to provide you with ample time to develop and refine your ideas. The registrations have already begun. I will explain you the process of getting yourself registered shortly. Meanwhile, let us have a look at further timelines. Project submissions will be open on 21st January and they will close on 22nd of February. So you have till late Feb to think of any ideas and build a small prototype of your idea. After this, the top 100 finalists will be announced where you will be receiving valuable mentorship and support from Google on how to scale your application, how to deploy it and lot more. Okay. The key points for submission criteria include prototype of the projects. That means your projects must be in a basic working condition. The next includes testing and iteration, demo video of project. So make sure it includes which of the 17 SDGs your project covers and what Google technologies you have used. You can use the last year's submission videos for reference. And at last we have scalability. After you have built the prototype, you should submit a plan to scale it. Later, when you get shortlisted, you will be assigned a mentor by Google who will be helping you achieve that scalability for your project. Coming to eligibility, it is open to university students above 18 years of age. Before that, you must have joined our community to become a member. To become a member, just go to gdsccommunity.dev, go to chapters, search our college name, just join here. Now, team building rules. The size of the team cannot exceed more than 4 members, and of course, the team members can be from different universities, different GDSCs, and different even countries. So, I will just explain you the registration process. So, first you have to fill the individual register form. You can scan this QR to fill it out. Once you have filled the form, identify a solution and form a team. You will have time till 21st January to form a team and build the project. After this, you can submit your project and get your team registered. You guys can scan the QR or I'll post the link later also. Teams gets a whooping prize of $12,000, which is $3,000 for each team member. The top 10 teams will be featured on Google's website, and the top 100 teams will be getting a certificate from Google and advice from Google experts to take your solution to the next level. So get ready to transform your passion into purpose, your ideas into impact. The Google Solution Challenge is not just a competition, it's a call to action, an opportunity to shape a better future. So let us code for change and innovate for impact. I can't wait to witness the incredible solution you bring to the table. Good luck and let the coding adventures begin. So with this we have come to end of the session. If you have any questions, feel free to unmute yourself or post your question in the chat box. Yes, Uzair will share the Apple PPTs, don't worry. Yeah, once the session is done, I will share the link. I will be sharing it in the GDSC MCET updates group. Yeah, WhatsApp group.
Imposter.